Hey everyone, we're going to evaluate the definite integral from 0 to 1 of absolute value of e to the power of x minus 3 dx. All right, here's a little figure of it. What we're going to do, I put this in the calculator and did this little graph. So we're trying to find this area in here. All right, and this is your log of 3 given here. So basically, to get these two different areas, you're going to set this, when you have absolute value, we're going to set this to 0. So we're going to say e to the power of x minus 3. And since it's absolute value, it's got to be greater than or equal to 0. And solving for x, we're going to get e to the power of x is greater than or equal to 3. Now, this can be written as e to the power of x is greater than or equal to let's see, e to the power of log of 3. Lost my train of thought there. All right, so remember this, when you have e to the power of log of x, that just equals x. So this equals 3. And then in this case, the e's would cancel because they don't cancel, but they have the same base. So basically we have x equals log of 3. So that's where I got this piece here. Now, we need to separate our areas here. So we want to look at when we're starting at 0. So we're going to look at case 1, and that's when x is in between 0 and log of 3. Well, that means that e to the power of x minus 3 by itself is less than or equal to 0. That means your absolute value of e to the power of x minus 3 is going to equal negative e to the power of x minus 3. All right, and now we want to look at the 1. So in case 2, that's going to be where we start at log of 3 and go to 1 on the y. So this should be 1 right here. So it should hit about right there. It's just a sketch. So for x is, we have log of 3 is less than or equal to x is less than or equal to 1. Then we have e to the power of x minus 3 is greater than or equal to 0. Or absolute value of x, e to the x minus 3 is just going to equal e to the power of x minus 3. All right, so we can set up our integral as two separate integrals and use the additive property. So we're going to have the integral from 0, we're doing the first case of log of 3, and we're going to write this one. So it's going to be negative e to the power of x minus 3 dx. Then you add the second area, and that's going to be log of 3 to 1. And that you write e to the power of x minus 3 dx. So now we're going to integrate both of these sides and evaluate. These are pretty easy to integrate. So e to the x, the antiderivative of e to the x is just e to the x, and the antiderivative of 3 is 3x. So we can write this as negative, keep the negative on the outside, and we're going to have e to the power of x minus 3x. And we're evaluating from 0 to log of 3. And then we had the plus, and we have e to the power of x minus 3x again. But this time we're going from log of 3 to 1. All right, so let's substitute everything in. This is going to give me minus e to the power of log of 3 minus 3 log of 3. Then we're going to have minus a negative, so it's going to be plus, because we have this negative still. So you put plus, and we have e to the power of 0 minus 0. And then for this one, we're going to write plus. Now we're substituting in 1. e to the power of 1 minus 3. And then substitute in log of 3. That's going to be minus e to the power of log of 3. And then we're going to have minus 3 log of 3. I'm going to rewrite this a little bit. So basically, this right here is just 3, like I said before. So that's going to be minus 3 plus 3 log of 3. Plus this equals 1 plus e to the power of 1 minus 3. Again, this one right here is just going to equal 3. So it's going to be minus 3. And then we have minus a negative, so this can be plus 3 log of 3. Now, let's see what we have. We have 6 of these, so 6 log of 3. And then we have this singular e here, plus e. And then we have negative 3 plus 1 minus. So we have negative 9 plus 1. So that's going to be minus 8. So this is your final answer. Thank you. Have a nice day. Bye-bye.